Hello! Well, in this episode of Finno-Ugric Machining, we are going to give some TLC for this vernier caliper. This is a Czechoslovakian made. Yes, Czechoslovakia, not Slovakia or Czech Republic. It's Czechoslovakia. Made vernier caliper, which apparently is not made out of stainless steel because it has stains in it. What we are going to do is to clean it up and make it usable. It's a little bit stiff. Mechanically, this is all right. I have checked it. I bought this from a flea market with 10 euros. And I know these are really superb quality. Yes, they really are. And then after that, when I have cleaned it up and made it usable, I will show you how to read these. You probably have a digital caliper which doesn't have this vernier scale. And for me, I have used these all my life. Well, when I have been using. I have a digital and I don't like it at all. So this one is really good, I think. For me at least it is. And it's simple, it's quite robust and you always need an extra. Let's first clean this up and after that we will go through how to read this. It's actually quite simple. I don't know about this. This can also measure inches, the so-called banana scale. But, this is something I also have to learn how to read, so bear with me. First the metric scale, then the banana scale. But first let's clean this up. Well, now this instrument is cleaned to a usable state. I did not want to make a mirror polish on it. It is a tool, after all, and the years of use should show out. It is now readable, and the measuring surfaces are clean and accurate. It also slides smoothly, as it should. First, let's see what is in the backside of this caliper. There is a table of metric threads. In this table we have nominal diameter, thread pitch, minor diameter, and tapping drill size. If I think about it, these are the values that I most often look out of my engineer's black book. Very handy, literally. The values in this table are not limited to the listed nominal diameters. Let's take an example that is not listed here. I have a M20 tap with 1 mm pitch, so what would the tapping drill size be for it? In the list you can see that the tapping size for 1 mm pitch is 1 mm smaller than the nominal size. So the tapping drill for that tap would be 19 mm. Let's take another example. The standard M9 thread, which has a pitch of 1.25 mm per revolution. The tapping size for a thread with 1.25 mm pitch is 1.3 mm smaller than the nominal diameter, which is 9 mm for a M9 thread. The tapping size for a standard quartz M9 thread is then 7.7 mm. This all works because the difference between minor and major diameters is not dependent on the diameter itself, but on the thread pitch. That's all about that handy table. Now, let's look into the vernier scales and how to read them. This caliper has two vernier scales. The top one is imperial and the lower is metric. The top one reads inches and the lower reads millimeters respectively. Let's take a closer look into the metric vernier scale. This is the millimeter scale, and each division is 1 millimeter. There is a longer line at every 5 millimeters. There is an even longer line and a number at every 10 millimeters. These numbers are also known as centimeters. The measuring line points to the current millimeter. With this line and the millimeter scale, a measuring accuracy of 1 millimeter can be obtained. Each millimeter can be divided into 20 0.05 millimeter divisions using the vernier scale. The measurement is read by first reading the whole millimeter by the measuring line and the scale, and then adding to that the fraction pointed by the matching vernier line. In this case, the whole millimeter is 0, and the fraction is also 0, so the measurement is 0.0. Let's take a more realistic example. In this case, the whole millimeter is 11. It's not 12, as the measuring line has not reached it yet, and it is not 10, as the measuring line is at or over 11. The fraction is 75, as the vernier line at 75 coincides with the millimeter scale line. So the measure is 11 plus 0.75, which is 11.75 millimeters. Let's practice a little bit. I'll reveal the correct value after 5 seconds. How about this? One more. I hope we got those right. Now, let's take a closer look at the imperial scale. This is the imperial scale, and each division is 1/16 of an inch. For each eighth of an inch, there is a longer line. For each half of an inch, there is an even longer line. There is a number for each whole inch. The measuring line points to the current 16th of an inch. With this line and the imperial scale, a measuring accuracy of 16th of an inch can be obtained. Each 16th of an inch can be divided into 8 128th of an inch division using the vernier scale. The measurement is read by first reading the whole 16th of an inch by the measuring line and the imperial scale, and then adding to that the fraction pointed by the matching vernier line. In this case, the whole 16th of an inch is 0, and the fraction is also 0. So the measurement is 0. Let's take a more lifelike example. In this case, the measurement is 2 inches plus 11/16th of an inch plus 4 128th of an inch. After some mind-twisting calculations, the final result is 2 inches and 92 128th of an inch. Often the fragment is beautified to a lower divisor out of 2, 4, 8, 16, 32, 64 or 128. In this case the beautified result is 2 inches and 23 32ths. Let's practice a little bit. I will reveal the correct value after 5 seconds. You might want to pause the video if you were not breastfed with inches and you need a calculator to get the beautified result like I do. Let's see what you get out of this one. One more banana for the road. I hope we got those right as well. Since this caliper can read imperial and metric values simultaneously, it can be used to convert values between those two, obviously. So now we have a fully working caliper which is cleaned up and it's really smooth. And these Czechoslovakian made calipers are really good. They are very durable. They are not stainless. They are made out of carbon steel, and they are hard. They are really hard. And now it's readable. You can read it quite easily. And it's in working order actually, and in the next episode we are going to go into this air oil separation filter thing, and finalize that one, but Well, I hope you enjoyed. I maybe also I hope you learned something here, especially if you are if you have a caliper like that and you have never used these, for example, the metric scale, or you have not used the inch, the imperial scale, the banana scale. So yeah, it's well, yeah. So I would like to thank a person in the cutting edge engineering Australia, Curtis, who well uses this banana thing all over the place, and he also received one one of these with a real banana scale, and that was sort of a funny thing. But yeah, okay. But I'll use that now. It's 10 euros. Yeah, and it's accurate enough. It's really accurate, actually. So for that price, and it's not Chinese. So till next time. Bye.